Hello, myself Gautam from 316. Today my topic is chemical kinetics and catalysis. So, chemical kinetics is the study of rates at which chemical reactions occur and the factors that influence these rates. It helps chemists understand how quickly reactions proceed, what influences the speed, and how to control or optimize them in various environments from laboratories to industrial applications. Its key concepts in chemical kinetics are: first one is reaction rate. The reaction rate measures how fast the concentration of reactant decreases or how fast the concentration of product increases. It is expressed as rate equals to differentiation of reactant per time, and it gives differentiation of product per time, where this is the expression defines the change in concentration of reactant or product per unit of time. Second is key concept, rate law. It relates the reaction rate to the concentration of the reactants. Rate law might be written as rate equals to constant, where k is the rate constant, m and r are the orders of reaction with respect to reactants of concentration a and b respectively. And third one is order of reaction. Order of reaction refers to the sum of the exponents in the rate law equation. It indicates how the concentration of reactants affects the reaction rate. Reactions can be zero order, first order, and second order. In zero order, the rate is independent of the concentration of reactants. In first order, the rate is directly proportional to the concentration of one reactant, and in second order, the rate depends on the square of one reactant concentration or the product of concentration of two reactants. Fourth one is rate constant. Rate constant is a proportionally factor in the rate law. Its value depends on the specific reaction and is influenced by temperature. The units of constant vary depending on the order of the reaction. Fifth one is half-life. These are used to determine the time for the concentration of a reactant to decrease by half time. It depends on the order of reaction, its first order reaction and second order reaction. Sixth one is integrated rate laws. These are used to determine how the concentration of reactant changes over time. This differ based on the order of the reactions, like zero order reactions, first order reactions, and second order reactions. Seventh one is collision theory. According to theory, molecules must go collide with sufficient energy greater than or equal to activation energy, and in the correct orientation to react, the frequency and energy of collisions affect the reaction rate. Eighth one is activation energy. Activation energy is the minimum energy required for a chemical reaction to occur. The Arrhenius equation expresses the relationship between the rate constant and temperature, where A is the frequency factor, EA is the activation energy, RA is the gas constant, and T is the temperature in Kelvin. As temperature increases, the reaction rate also increases due to more frequent and energetic collisions. Here is the formula. And ninth one is a reaction mechanism. Most reaction occurs in series of elementary steps rather than a single step. The reaction mechanism is the sequence of these steps. The slowest step in the mechanism is often the rate determining step, which controls the overall rate of the reaction. Now, the application of chemical kinetics. The chemical kinetics is essential in fields such as in industrial chemistry, environmental science, pharmacology, and food science. Understanding kinetics allows chemists to control reactions more efficiently, which is vital for product development and safety. And now our second topic is catalysis. So, what is catalyst? A catalyst is a substance that increases the rate of a reaction without being consumed in the process. It works by the lowering the activation energy, providing an alternative reaction pathway. Catalysts do not affect the overall thermodynamics of the reaction but accelerate the kinetics of the energy. What is catalysis? It refers to the acceleration of a chemical reaction by a catalyst. A catalyst is a substance that increases rate of reaction without being consumed or altered permanently. It works by the providing an alternative reaction pathway with a lower activation energy. So, types of catalysis. There are three types of catalysis: homogeneous catalyst, heterogeneous catalyst, and enzyme catalyst. So, homogeneous catalysts are the catalyst and reactants are in the same phase, usually in or liquid or in gas shape. Example: acid catalyst esterification. Second is heterogeneous catalysis. In this, the catalyst and reactants are in different phases, typically in a solid catalyst with a liquid or a gaseous reactants. Enzyme catalysis. In biological systems, enzymes act as a highly specific catalyst for biochemical reactions. So catalysts work by providing an alternative reaction pathway with a lower activation energy. This means more molecules can achieve the required energy to react, which increases the rate of reaction. Catalysts do not change the equilibrium position of a reaction, they only help the system to reach equilibrium faster. So, what is the importance of catalysis? Where its importance are used? There are three importance in industrial application, in environmental impact, and biological significance. Industrial application for ammonium production, environmental impact for automobiles as catalytic converters, in biological significance, enzymes as biological catalyst. So at the end, catalysis plays a crucial role in both everyday chemical process and advanced technological applications, making it a cornerstone of modern chemistry and industry. So thank you.